This video will focus on Georgia Standard of Excellence 5 NBT 3, Understanding the Place Value System. Students should be able to read, write, and compare decimals to the thousandths place. More specifically, students should read and write decimals to the thousandths using base 10 numerals, number names, and expanded form. Students should also be able to compare two decimals to the thousandths based on the meanings of the digits in each place, using greater than, equal to, and less than symbols to record the results of the comparisons. The vertical progression for decimals begins in 4th grade, where students are introduced to the idea that fractions with denominators of 10 and 100 can also be written using our place value system. This is a big idea that students need time to develop. Students should engage in various decimal activities to make sense of this idea so that when they are asked to apply this understanding in 5th grade, the decimal notation will not get in the way of their work with these decimal numbers. Also in 4th grade, students extend their understandings of place value to whole numbers, connecting number names and expanded form to the whole numbers themselves. Students build on this understanding in 5th grade when they begin connecting decimal number names to the meanings of the decimal numbers and their expanded forms in order to make sense of them and compare and operate with them. In this first video clip, watch as the teacher uses an opening activity to get students thinking about decimals.
So for today's lesson, your large cube is your 1. So your large cube is your whole. Awesome. So are we ready to roll?
Yes.
Okay, so your first task, I'm going to model for you, and with your team to kind of warm us up and get our brain going, you're going to answer these 3 questions as a team. Okay? So you're going to look at the models that I give you. If the large cube is the 1, what values are these models representing? Second question, which value is greater? Third question, how can you prove it? You have a judge in here, they're saying you've got to prove to me which one is greater. What is your evidence? How can you prove it? Okay? So are you ready for your models? Yep. Alright, I'm not going to tell you what they are. You've got to figure out what values they are. Okay. You are comparing this value to this value. What are those models representing? Which one is greater? How can you prove it?
Pause the video here, and with your team, discuss the following questions. What do you notice about this opening? What misconceptions do you anticipate? And how would you address these misconceptions?
So if I were to ask you, without even knowing the numbers that go along with these models, which model is bigger? Why? How do you know that? Just by looking, if I was a 3rd grader and I came here and I didn't know anything about decimals, which one would I say is larger?
I want to say that.
Why?
Because it looks like it looks like
Takes up more space, right? There's more value there.
And also, since you could add another 0, it would be 200.
200 what?
200,000.
Okay, so you're saying there's 200 thousandths here because we said 1,000th was the small cube, right? And we know there's 100 thousandths, 200 thousandths. How many thousandths are here? You see 200?
This is 20.
Okay.
Think about it.
Okay, so which one is larger? 200 thousandths or 21 thousandths? Alright, so talk about how you can prove it.
How we can prove it is that this full one has 100 of these. Yeah. So then that means that this would be 100. And double it would be 200. And then there's 10 of them. There's 10 of these in the rod. So then that would be 1, 2, 3, 4. And then double it would be 20. So that would be 21, 21, 200. And that's how we can prove it. Oh wait, this
During the opening, students were asked to compare two decimal representations. Many students named these representations incorrectly as 21, and 200. This lack of attention to precision was anticipated, and the teacher used a brief classroom discussion to bring this to light and wrap up the opening.
So we thought this one was 200, and this one is 21.
Okay, so 200 holes and 21 holes. Even though the cube is our 1?
So these are 2 tenths,
Okay.
and this is 1,000.
200s and 1,000, absolutely. How would we say that? Tristan?
21 thousandths.
Okay, so we see 21 thousandths in that value there because 1,000 is here, right? So we have 21. But Emma kept saying 200. What does she mean by 200? Austin?
Okay, so if those two are 2 tenths, they could equal 20 hundredths, and then you could equal 200 thousandths, and all it is just 2 tenths, and you can just keep on going.
Now watch as these students work with their groups and use their beginning understandings of NBT3 and the precision of language required to compare decimal numbers by creating their own representations.
13 hundredths is greater than 31 thousandths because 13 hundredths is greater, or it's more closer to 1 whole than 31 hundredths. And this has a tenth in it, and this one doesn't. And this one is closer to the 1 than this one.
What do you know about tenths?
Well, tenths are greater than hundredths and thousands.
And how do you know that tenths are greater? You can focus. How do you know that tenths are greater than hundredths?
Okay, because if you want to get the model out? Yeah. If this is if that's a 1 whole, this is a tenth, and there's 10 tenths in 1 whole, and then this is a hundredth, and then the hundredth goes. There's 3 hundredths, and then there's one of these, and then this one has 3 hundredths, but it doesn't have any of those, and it just has some of these. And this one is closer to that because there's 10 of these and that.
In this activity, the teacher designated the large base 10 cube as the whole and allowed students to determine the values of the other blocks. The problem students often have is that they are naming the blocks rather than focusing on the relationships between the blocks. For example, students compare 21 hundredths to 21 thousandths, and they build the base 10 representation, but they look at the numbers. This one has more digits, so students think it must be greater. So how do we build relational understanding with decimals? Here's an arrangement of base 10 blocks, and here's what we know about them. This little decimal point is really helpful. What do you notice? Pause the video here and talk with your team. The decimal is looking at the unit, the ones place, and it always does. In this case, we have the number 1,257. But what if the decimal point was here? What is the unit? The decimal tells us. Once I know that, I know the tens, the hundreds, but what about these? Remember, the unit here is the rod, and rods can be decomposed into 10 parts. One of these parts is 1/10 of the whole. That means every one of these pieces is 1/10 of the whole. And when I have 10 of them, I can put them back together to make the whole. So now I know that these are tenths, and the number represented here is 125 and 7/10. Let's try another one. We'll just shift these cubes to the right a bit. What just happened to the values of every digit in our number? What's the new unit? Pause the video and have a talk with your team. The decimal names the unit. and the unit is the large cube. So now I know that these are tenths because it takes 10 of them to make the whole. I know these are hundredths because it takes 100 of these rods to make that large cube. And these are thousandths because it takes 1,000 of these little cubes to make the large cube. And my new number is 1 and 257 thousandths. And if we shift it one more time, the decimal names the unit. They're the ones. Now I can name the tens, the tenths, and the hundredths. And my new number is 12 and 57 hundredths. Using the decimal point with the visual representations gives students the opportunity to build relational understanding of the decimals and deepen their understanding of the base 10 system. This activity is called The Decimal Point Names the Unit and can be found in the links below this video. Another test to consider is High Rollers Revisited. This is a game where students create decimal numbers with rolls of a die and compare their decimal numbers with their partner to see who created the greatest decimal number. And Decimal Lineup, where students use number lines to accurately place decimal numbers based on the benchmark numbers given. For additional support and resources, please visit GeorgiaStandards.Org, where you can access additional tasks, intervention materials, and more.